So now let's proceed further with mass and weight. Okay, so let's go further with mass and weight. Okay, so basically mass of a substance is the amount of matter present in it. Okay, mass of the is the amount of matter present in it. How can I define it? The words only. Whereas the weight of the substance is the force by which the earth attracts the body of mass m. So let's just say the mass is m. It's the amount of substance present inside this body, whereas the weight is the force of which the earth attracts a body of mass m. This is weight and the mass is this. I can define like this only. Mass of the substance is constant everywhere, every time. And that's just obvious. How can something internal can be changed? Whereas the weight of the body changes with respect to gravity, you can say. Like if you are here on earth, the weight is something, on moon, the weight is something. We all must have studied this thing before also. The unit of mass is kilogram, whereas the unit of weight is kgf. The kilogram and force. Because it is a force, it is kgf, kilogram force, and mass is kilogram. Okay, so we are done with this. Now basically, now we are coming to volume. Basically, volume is the amount of space an object occupies. Okay, now volume is the amount of space an object occupy, and it is having its unit. Everything will have a unit also. So unit is equal to the cube of length. So let me just first write this one. Volume is the amount of space. Suppose that this is a marker. It is occupying some space, So this is the volume of the marker. Okay. So volume and its unit is equal to the cube of length. The whole cube. Okay. So volume is the cube of length. Unit of volume is cube of length. Like for example, we can say centimeter cube, meter cube, decimeter cube, and all that stuff. Okay. So there's also one more unit, the liter thing. So 1 liter is also there as a unit, but we need to remember that 1 liter is equal to 1000, or you can say 10 to the power of 3 centimeter cube. So why I have written this? Like, let's suppose there's a box. So of dimensions 10 centimeter by 10 centimeter and by 10 centimeter. 10 centimeter. So this box, this whole box will be occupying a volume of 1 liter. Or you can say that 1010 centimeter cube. Or you can even write 10 centimeter whole cube. Anything like things like this are accepted. Okay, so 1 liter is 1000 centimeter cube, and the volume is the amount of space occupied by an object. Okay, so now we have defined the volume and mass, so we can relate them. We can relate we can relate them as density. Okay, so density. Now basically, density is the ratio of mass of an object upon the volume occupied by it. Okay, Density is the ratio of the mass of an object to the volume occupied by it. So basically that's it. I mean, density do have a unit. We can derive it. Like the SI unit of mass is kilogram. The SI unit of volume, I mean there's no SI unit. We can take units. So let's take liter, or even we will do with centimeter cube. So the unit goes for kg per liter, or kg liter minus 1. The both are same thing. And now if we take centimeter cube, we goes for kg centimeter the whole cube minus 3, or kg per centimeter cube. Both are same thing. I mean this or this same. Okay. So now coming to temperature. I mean that's a basic unit, not a derived one, but there are different scales of temperature, like the Kelvin scale, the Celsius one, and the Fahrenheit scale. Okay. The SI one is the Kelvin scale, but I mean more scales are there, so we have to study. So 3 different scales: Kelvin, the Celsius, and I mean like, yeah, obviously Kelvin, Celsius, and Fahrenheit. I guess they are spelling in. Yep, it is Fahrenheit. Sorry, there was a spelling error. So there are 3 scales: Kelvin, Celsius, and Fahrenheit. So now let's just quickly understand them. As we all know, Kelvin scale have 100 divisions. I was about to say 1000. Similarly, the Celsius scale also have 100 divisions. But the Fahrenheit scale is having 180 divisions. So that means that if we rise by 100 divisions here, we will also rise by 100 here, but we are going to rise by 180 divisions on this scale. Okay. So that's just the definition. All the 3 scales are related to each other in same thing, all are temperature. So we can just convert from one to another. So let's just simply understand the formulas. There's nothing to understand, but let's just remember them. They are quite easy. Okay, so first we will do from Kelvin to Celsius. From on Celsius or Fahrenheit, we write degree Celsius or degree Fahrenheit. But Kelvin, it is only Kelvin, no degree or anything like that. Okay, so we were here. Let's do just this. K is equal to degree C plus 273.15. So this is the equation. From Celsius to Kelvin or Kelvin to Celsius. This is the exact value. Some of you can to simplify things, 273 only, but it is preferable and more accepted to write 273.15. That is more accurate. It will increase your difficulty of doing this question. The things will go complicated, but the answer will be much more accurate. Okay. So we have done from Kelvin to Celsius. So let's do from Celsius to Fahrenheit. From degree C to degree F. Okay. So there's only that's not just simple as like that. 9/5 degree C plus 32. This is a formula. We can remember this thing quite easy. Fahrenheit is equal to 9/5 of the temperature on Celsius plus 32. That's it. That's not that difficult. We can remember it. Okay. So we should also understand that negative values of temperature are also possible in Kelvin. No, in Celsius as well as Fahrenheit scale, but there is no negative in temperature in Kelvin, as I mean the Kelvin is not negative, that is not just possible. Till date nothing have been found, I mean below 0 Kelvin. Yep, centigrade of Celsius or Fahrenheit are in negative, like -10, -20, but Kelvin is not there. Okay, so that's it basically.